Hello all, welcome to Tutlings. We are going to see how to deploy a VLAN based REST API on Azure platform. Without further ado, let's get started. We will start off by creating a new repository on GitHub. So here I am on my GitHub account and I'll go ahead and create a new repository. Let's say we name the repository as VLAN-API. So we'll click on add a README file and we'll go ahead and click on creating repository. All right. So let me copy the URL of this repository so that I can go ahead and clone it on my local PC. So here I am on the local PC and I have connected to the command line terminal and git space clone space the URL that I have just copied, and the repository will be cloned onto my local PC. I'll cd into that repository vlang-api, which is the directory name same as the repository name, and I'll open the Visual Studio Code. Now open the terminal and check the version of V even before we start working on creating our VLAN based web API. So for that we need to type in V space version. That will print out the latest version that is installed on your PC. At any point of time, you can upgrade your version of V installed on your PC by typing V space up. As I already have the latest one, I'll go ahead and create a new module named app. For that, I have to type V space new space app. So I'll go ahead and update the description and also enter the default values for the other fields. You will now notice a new directory named app in the Explorer section, right? So if you expand that, you will find the app.v file along with the module file. So we will go ahead and replace the contents of app.v with this. Now we will go ahead and create another v file within the app module, which will be named as node.v. This file contains a struct that represents a node, which is again attributed with table that represents the name of the table in the database, and it has a struct method to_JSON that casts the object to JSON format, and this file also has various REST endpoints. Post will create a node. The next endpoint retrieves a node given its ID. The subsequent endpoint gets the collection of nodes, and this endpoint updates a node given its ID. And finally, we also have a delete node endpoint that is attributed with node/id, and it deletes the node given its ID. We will now go ahead and create another V file which will be named as util.v. In this file, we will have our common functionalities applicable for our REST API, such as constants or custom responses that are applicable for all the endpoints. If we look at the app.v, the main function connects to the SQLite database and it will drop the table if it exists and recreates the table node every time we restart the application. We are also importing SQLite because we are relying on SQLite database in this REST API application. If you look at the other lines in the main function, we also have defined the HTTP port, which is the port that this application runs on, which is 8080. We then finally run our vweb based REST API by providing arguments app and HTTP port. App has the instance of vweb context and also mutable property of the database. And there is a default endpoint also. When we land on the home page of this app, we will be greeted with a welcome message, welcome to Tutlings. Now we will go ahead and run this app. For that, all we have to do is type v space run space name of the module, which is app. and hit return, the console prints that it is running on localhost port number 8080. And we also see that there is a notes DB that is created, which is a SQLite database as we have configured in our main function. So let's move ahead and open up this default homepage in our browser of our choice. Okay, we can see the welcome message. Now we will open the Git bash and send curl commands to add nodes. Yeah, this is the first curl command. To keep things simple for you, I'll go ahead and update the readme file with the list of curl commands that are being used in this tutorial. So I'm updating the readme.md, and let me add another note by sending the curl command with different payload this time. Alright, so now we will look at the list of nodes that are just now added by sending one more curl command, which retrieves the list of nodes as shown here. Now let me stop this application running on localhost, and finally I'll make one change, which is moving the .gitignore file to the root of this project. We will update the gitignore file by adding an entry to .db file types. .db file types are generated because we are using SQLite as a database and they cannot be a part of our code base. Now we will go ahead and get ready for the deployment. For that, we will Dockerize our application. For that, in the root of our applications directory, we will create a file named Docker file with D in uppercase. So the Docker file will be created out of a base image, which is again the base image that is offered to us by the VLAN. Here you can see I am on the Docker Hub. The VLAN is the official user that actually publishes the standard VLAN images very frequently onto this repository. The latest tag can be found in the tags section, and it is identified by the name latest. So our base image will be pulled from the VLAN/VLAN:\latest. Now we will optionally create an environment port that has a value 8080. As we are running our application on a HTTP port number 8080, which can be observed from app.v as shown here, we have to expose this port number 8080. So we'll go ahead and update our Docker file by adding a line expose space 8080. Now we will go ahead and create a work directory for our container. So this will be the code directory, and the next thing is we will be copying the contents of our project which are available in app directory relative to the root of this application to the code/app directory inside the container, which is represented as shown on the line number 8. As the application code is copied inside the container, we have to run the application inside the Docker container as we did on our local PC, which is by issuing a command run app. Similar can be reflected onto the Docker file with the help of an entry point, which is all uppercase, followed by an array of arguments which will be all lowercase. As we can see here, v in one array item, run in another array item, and then finally the name of the module, which is app. Now we have Dockerized our VLAN based web API. We'll make one final change to our gitignore. Let's remove this line app because it indicates the app directory which holds our code base. Now we will move ahead by checking in these changes and pushing these changes to our remote GitHub repository. Now I can see that my changes are reflected on the GitHub. We'll go ahead and create a GitHub action by navigating to Actions. Our GitHub action will be actually creating a image that is a resemblance of our VLAN API and pushes it to the GitHub container registry ghcr.io. So in order for us to be able to do that, we have to choose publish Docker container. If you can't find it, you can also go ahead and search for it with the name publish Docker container. And then in the results, you find that and click on configure to land on the configuration page of that particular GitHub action. We don't have to modify anything and we can simply go ahead and start commit directly to the main branch. But let's look at what is inside this YAML file. So we have various actions such as on schedule as mentioned in this cron. This image will be pushed based on the configuration mentioned in the cron. The other thing is on push to the particular branch named as main. This action will be executed. For the demonstration purposes, I'll go ahead and remove the cron schedule that actually triggers the creation of the image on a periodic basis. When you create a pull request against the branch main, this action will be executed. If you look at further down, you will see the environment section, which is actually pointing to the registry ghcr.io. When it comes to image name, it is actually the environment variable github.repository, which is Vincent/VLAN-API in my case. So if we look further down, we have various build steps in the jobs section, and all these jobs run on Ubuntu latest instance that is provided to us, which is the build runner. It also has various permissions mentioned in the permissions section, and the steps such as checkout repository is the first amongst all, followed by install Cosign, which is like a library or a package we can often say to sign the image that is built by this action. We also see a step Docker buildx that helps us build the Docker container, and followed by the login into the Docker registry, which is ghcr.io. It also has extra Docker metadata, build and push Docker image to ghcr.io. The last step signs and publishes the Docker image to the ghcr.io registry. So we will go ahead and commit this file directly onto the main branch. So upon successful committing, if we navigate back again to the actions section, it hardly takes 45 seconds to 1 minute to run this, and once it is done, you will see the build will have each and every step that we have in our YAML file. If we look at the Docker build and push step, this has the actual code which is a replication of each and every line that we have defined in our Docker file. As you can see here, we are pulling the base image version, which is actually being pulled from the VLAN/VLAN repository available on Docker, and then we are setting the work directory as code. Then we are copying the app directory contents to code/app. We are actually building the image and finally pushing the image that we have built to the ghcr.io, which is GitHub container registry. As we can see that the build succeeded, we can see the package generated by this GitHub action in the home page of the repository under the packages section. You will find the package, click on it, and you will see the Docker images that are being generated by the GitHub action that we have configured so far. Under the recent tagged image versions, click on main. You will see the command to pull this particular image tagged as main, or you can see how to use this as a base image in any other Docker file.
Now I'll go ahead and create an Azure App Service. Here I am on Azure portal. Click on the menu and click on the App Service section and click on Create. Create a new resource and we will be naming it VLAN-API-RD and click on OK. Now we will be giving the instance details. The name will be VLAN-API and you will access this application when deployed through this URL vlan-api.azurewebsites.net. Now we will go ahead and choose the publishing type, which will be of Docker container, as we have the Docker file. Right, the operating system will be Linux, and the region will be ECS2. And now we will choose the app service plan. Click on change size. Navigate to the dev test tab. We have options F1 which is free and B1 which is basic plan. I'll go ahead with the B1 and click on apply. We will rename the app service plan by clicking on create new and giving it a proper name. So I'll be naming it ASP as in app service plan dash VLAN dash API and click on OK. We notice that the SKU and size got reset. So let's change it back again to basic B1 plan. We will now move to the next step, which is setting up the Docker.
For the options dropdown, we will go ahead with the single container. The image source, we will choose private registry because I don't see ghcr.io on the GitHub container registry here. The server URL will be https followed by ghcr.io. The username is something that you generally use to log into your GitHub account, and same is the password that you use to log into your GitHub account. The image and tag will be Vincent slash VLAN dash API is the image part and tag will be the main. Both will be separated by a colon as shown here. So copy the image and tag part as highlighted here and paste it here. Ensure that you are not making any mistakes here. I do not have any startup command, so I'll go ahead and click on next to land on networking tab. I'll leave the default value off for the enable network injection. Next to land on monitoring. Here also I'll leave the default values, which is selecting no for application insights, and I'll move ahead further and click on tags. Let's move ahead. We don't have anything to do here as well, but if at all you have tags, you can add them here. Finally, we will land on review plus create. Here on the review page, we see the summary. The basic B1 is a SKU, and the resource group, as we have named here, the name of the app is VLAN-API. The publish mode, which is important thing to notice here, is Docker container, and the image tag will be Vincent slash VLAN-API followed by main tag, and the server URL is ghcr.io. The app service plan is having a operating system Linux and the rest of the details as shown here. So let's go ahead and click on create. It will take around 3 to 4 minutes for Azure to create this app service. Once the deployment is complete, click on go to resource and we will land on the Azure app service that we have just deployed. If we land on the app service that we have just created, we will see the application error. In order to successfully deploy this, we have to make some final tweaks on the app service. For that, the first thing we have to do is in the side navigation pane on Azure app service, under the deployment, open the deployment center where you will have access to settings, logs, and FTP credentials. Logs tab is the place where we see container log. As we see here, the image pull failed. The reason for failure is as it is trying to pull the image from Docker IO, which is the Docker Hub registry, even though we have configured the server URL as ghcr.io, which can be looked and set through the settings tab. So let's go ahead and reset our changes by entering the password one last time and applying those changes by clicking on save. Now let's move to the overview section and we will restart our Azure app service and we will navigate back to the deployment center and we will try to access the container logs and see if the app service is able to make successful connection to the registry, which is GitHub registry. Now we can see that app service is downloading the image from ghcr.io successfully, which is visualized from the logs that are being logged. To see the updated logs, you can click on the refresh option that is available, and also you can click on download to download the logs. After the image is pulled from the registry successfully, it is now trying to extract the image. We can see from the logs here the pull image successful, and it took 1 minute 35 seconds to do so. And after that it tried to start the container by issuing a command docker run followed by various arguments. That also includes various app settings which can be observed in the app service settings. As we see that the initial request is waiting for the response to warm up for the container. It will take around 4 to 5 minutes, so we will come back after the initial request succeeds. We see that the container did not respond to the HTTP pings on port number 8080, failing the site to start. The reason for that is Azure App Services that are having the publishing method of Docker containers suffer from the problem of picking up the port properly. In order to get around with this problem, we have to add an app settings, which can be done by navigating to settings. On the application settings tab, find the button new application setting and click on it. Now we will add an application setting with the name websites_port all in uppercase, and the value will be 8080 enclosed inside the quotes. Click on OK. Once you are done, do not forget to hit on save and continue with the changes. We see that the app settings got successfully updated. We will now head over to the overview and we will restart our app service in order for these app settings to reflect on the container. Now we will browse the application and we will land on the home page that reads us with the message welcome to Tutlinks. Let's look at the container logs one last time. So we will navigate to the deployment center, look at the logs, and we will refresh the logs to catch up with the latest logs that are generated, and we will see the message container VLAN API initialized successfully and is ready to serve the requests. We will also notice the new environment variable or the app setting that we have added reflects as one of the arguments for docker run command as highlighted here. Now let's switch back to VS Code and we will change our readme. Instead of localhost, we'll point out to the app service URL followed by the nodes endpoint, and we will try to add 2 nodes directly onto the hosted instance of our VLAN web API. And then finally we will retrieve the collection of nodes by sending a GET request. Now we post it again for the second node to be added. Now we will see the final command, which is to get the collection of nodes. As we see from the response, it is evident that we have retrieved a collection of nodes that we have added so far. This marks the completion of this tutorial. If you are interested in learning V programming and are new to this programming language, you can go ahead and buy my book Getting Started with V Programming. It is available worldwide on Amazon, backed publishing website, and other popular book selling websites online. The code that is used in demonstrating this video is actually being thoroughly described from the scratch in chapters Introduction to JSON and ORM, Building a Microservice. I hope you benefit out of this video. If you found this video helpful, please give it a like and please do share it with your friends and colleagues. Please do subscribe to my channel. Have a great day. Bye.